Hey folks, here's a little video going over the conjunctions and disjunctions in logic, which is basically ands and ors. We're also going to introduce you to truth tables, and truth tables are really cool. Actually, I think I had 3 classes in college that used truth tables. Oddly enough, well, not oddly enough, a math class definitely had them. And then a psychology class had them, and that makes sense because logic is very psychological kind of stuff. And then the weirdest of the bunch was I had this one English class that used truth tables. I don't know why. Well, you can see it's kind of Englishy. But conjunction, remember conjunction, junction, what's your function? Is the word and. There's also but, right? Those are 2 words that hook up phrases. The word and, right? The symbol for conjunctions is going to be an upside down V, sort of. So if you had P and that symbol in Q, you would say P and Q. Okay. The only times you use but is when the first part is positive and the second part's negative. But we'll cross that. Hear that? But we'll cross that bridge when we come to it. So conjunctions, the conjunctions of, let's see, the conjunction of 2 statements. We've never used 2 statements together yet in logic. P and Q is true only if both P is true and Q is true. It's false otherwise. So and is very strict. Okay, and is a very strict thing. Think about this. What if I made a statement like this? I had a statement, it is Tuesday and it is cold outside. Okay, so if P is it is Tuesday and Q is it is cold outside. Okay, what if I made the statement, the whole statement, today is Tuesday and it's cold outside. Okay. So in order for that statement to be true, which by the way would be represented by this, P and Q, there's P, there's the word and then Q. If I made this statement, the only way this whole statement would be true is if both parts are true. So let's say it's Monday, and I made this statement. I'd say, today is Tuesday and it's cold out. It doesn't matter if it's cold out or not. You would say, you are a liar. Okay? Or, let's say it was like 95 degrees out, and it was Tuesday. If I said, today's Tuesday and it's cold out, you'd say, you're crazy, man, because it's not cold out. So in order for an and statement to be true, the only way this can be true is if they're both true. So now we're going to talk about truth tables. So this is your first introduction to truth tables. A truth table looks like this, and you have a few options with P and Q. If you have 2 statements, they could both be true. You could have the first one true, the second one false. You could have the first one false, second one true, or you could have them both false. There is no other way to take 2 statements. Okay? So if I want to look at what a picture, a truth table, is a great way to organize logic, because remember, an and statement, the only way an and statement can be true is if both parts are true. So if I said a true statement and a true statement, it's true. If my first part was true and my second part was false, I'm a liar, right? If my first part was false, like it's Monday, even if it's cold outside, the whole statement's false. And if I lied about both, I'm definitely a liar. So this is what the truth value of an and statement looks like, and it covers every situation. Just remember that and is strict. If either part of an and statement is false, then the whole thing's false. Okay, similarly, A disjunction is using the word or. I guess you could use the word nor too. And the symbol for that is this. Sometimes you'll see it written as a symbol. It's a V looking shape. Sometimes you'll actually have the word or in there. Okay? And these are called disjunctions because you're splitting things up. Okay, so the disjunction of two statements is false only if both P is false and Q is false. So this is the opposite, really. It's kind of very lenient. If and is strict, then or is lenient. Okay, it's not strict. Okay, so think about this. Same two statements. It's Tuesday out and cold. If I said, if I did this one, P or Q, it would look like this. Either, I'm using it in grammatically correct sentence, either today is Tuesday or it's cold outside. Okay, so with this statement, if let's say it was Tuesday and it's cold outside, that's true. Okay, so I think most people are cool. Here, let's set up a truth table and kind of hit them one at a time with the sentences. P or Q. Let's say, okay, P, let's say we had true, true. So let's say today was Tuesday and it's also cold outside. See how this statement holds up. Either today is Tuesday or it's cold outside. Is that whole statement true? Yeah, I mean, both of them were true. It's definitely true. Now, here's where it gets a little different than and. It's because if the first part's true and the second part's false, is my whole statement true or false? Because I have the word or in there. So let's say it was Tuesday, but it was hot outside. And I said this statement. Either today's Tuesday or it's cold outside. Is my statement true? Yeah, because the only way to make an or statement false is if they're both false. So even if it was Monday but it's cold outside, my statement's not wrong. I'd say, hey, either it's Tuesday or it's cold outside, and one of those was true, then the whole thing's true. The only time it doesn't work is this. So let's say it was Monday and it was hot, and I said this statement. Either today is Tuesday or it's cold outside. You'd say, you're crazy, man. Okay, so if and is very strict, where the only way to get through is to have them both true, or is very lenient, where if either part of it's true, the whole statement's true. Negation we've already talked about, but we didn't talk about the symbol for it. Usually you use the word not, but not always. So the symbol, I think we might have done the symbol for it. The symbol for a negation is the tilde, the squiggle. So you'd say, okay, if your regular statement was, I don't know, hold on. If my regular statement was all cats are sneaky, right? That's a universal statement. So a negation of that would be an existential. You'd say some cats are sneaky. And if this is P, this is not P. Right? Usually we put statements in quotes too. Okay, so what's that look like on a truth table? It's a lot less interesting because if you only have one statement, it's either true or false. It's not as cool as these. So then the not version, well, not true is false and not false is true. That's not too crazy. All right, so a couple weird terms to add to this. De Morgan's laws. Actually, let's do tautology next. We're going to jump around a little. A tautology is a statement that is always true. So if you did a truth table and everything came out T, 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 you just found a tautology. For instance, if I said either it is light outside, or, well, either it is day or it is not day. You thought I was going to say night, didn't you? But night, there's always dusk and dawn. So if I said this statement, either it's day or it is not day, you would have, your first statement is P, your second statement is not P, and if I did an or with them, remember, or is lenient, okay? So or, if either part of it's true, true or false, so if it was day, this whole statement's true. If it was not day, this whole statement's true. So this right here, oops, it's a not symbol. This statement here, since they're all true, is a tautology. And the reverse of that is a contradiction. Contradiction is a statement that is always false. Okay, and statement that's always false, you'd say every month has 37 days, right? Right, that's false, always. So you could say a number's, anyway, a statement that's always false is going to end up being called a contradiction. A statement that's always true is a tautology. Logically equivalent means statements that have the exact same truth value, like every time. So like these don't match up because even though the top and bottom are the same, right? See how it starts with true and ends with false, starts with true and ends with false, but because there's anything at all different, it could just be one of these different, then they are not logically equivalent. The only thing that would be logically equivalent to this is another one that turned out TFFF, or the only one that would turn out logically equivalent to this would have to be TTTF. It happens a lot, so we're going to do a couple examples. But before we do, actually, this is a good example of it. De Morgan's laws are, if you ever have a not in front of an and, what does it do? Okay, not P and Q actually turns into not P or not Q. Okay, so it's kind of like this not distributes to both pieces, but it also changes your symbol. And similarly, here's another one of De Morgan's laws. If you had an or statement, it would sort of distribute in to mean not P and not Q. Okay, it's sort of like the distributive property, but the symbol also changes. And like if I wanted to use this with statements, you could do it with like our one earlier with Tuesday and cold outside. This statement would say, it is not the case. That's what, if you ever have a not out in front, it means it is not the case. So you'd say, it is not the case that today is Tuesday and it's cold outside. This one would say, it is not Tuesday or it is not cold outside. These two things are logically equivalent, and in the next video we're going to build these and show you, because it's part of your homework. But we'll do a couple examples with truth tables. This one, if I were saying it, I would say, it is not the case that it is Tuesday or it's cold outside. This one I would say, it is not Tuesday and it is not cold outside. So these are logically equivalent statements. They're called De Morgan's laws. It's sort of like distributive property. All right, next video we're just doing a few examples to get you comfortable with truth tables.